Guys, a lot of you have been asking how I achieve this outline effect in my project. Well, today is the day. I'm going to show you exactly how to do it, and you see, I've set it up in a really simple way. No complex stuff like post-process materials, blueprint setup, just one material. Let's dive in. Let's take the famous link as an example to illustrate everything. When I first developed the outline material, my goal was to keep the original material of any character intact and simply add the outline effects on top of it. Luckily, Unreal already provides us with a great tool for this, the overlay material, which you can find in the details panel of your skeletal mesh assets. This feature allows us to create an outline effect that works in addition to any existing material, making it a non-destructive and effective solution. Exactly what we want, right? Now let's create the material itself. We'll start with the standard material assets, which you can access directly in the content browser. The first step is to change the blend mode to masked, as we need control over the material's opacity. Next, we'll adjust the shading model. For sharp, well-defined outline, we'll use the unlit model. Also consider enabling the two-sided attributes, as it can help improve the effect. To begin, I'll show you the core concept behind this kind of material, and then we'll add more advanced features to refine and control the effect. First, let's create a color parameter to allow basic control over the outline color. It's always a good practice to rename and categorize your parameters, especially if you're working in a team. Since we're using an unlit shading model, the color is driven by the emissive input. This means that if you want to tweak the intensity, for example, you can easily add a multiply node and a scalar parameter to adjust the emissive brightness dynamically. Once that's done, you can focus on the outline effect itself. To better understand what's happening, let's create a material instance from our master material and assign it to the overlay material attributes of the skeletal mesh. As you can see, at first, the overlay is too strong. You can't see the original material at all. That's where we need to control the opacity of our outline material. Back in the material graph, we'll define the opacity input. The best and easiest way to create an outline in Unreal is by using the two-sided sign node along with world position offset. The two-sided sign node helps us differentiate between the front and back faces of the mesh. It outputs 1 for front-facing normals and -1 for back faces. By default, Unreal operates on 1, meaning the material applies to the correctly oriented faces. This node is commonly used to assign different colors to the front and back faces of a mesh, or to adjust normals, especially in foliage materials. Here we'll use it to base our logic on the back faces of the mesh, ensuring the outline effect doesn't completely obscure the original material. Then we'll push these back faces outward using world position offsets, effectively creating the illusion of thickness. To apply this correctly, we can use a -1 and plug it into the opacity input. For the world position offset input, we'll use the following setup. Take the vertex normal WS node, which gives us the world space normal of the mesh. Multiply it by a scalar parameter, which we'll name outline width. This setup allows us to control the outline's thickness dynamically. The same technique can be used to create effects like snow accumulation on top of a mesh by simulating surface growth or shrinkage. So if we plug this world position offset logic along with the opacity setup we just created, we can now jump into our scene and check our material instance. If you increase the outline width, you'll immediately see the outline effect appear on the skeletal mesh. Since we're modifying the back faces of the mesh, increasing the WP or vertex input pushes them outwards, creating the illusion of an outline. It's as if we are growing a mesh from the inside. The black color starts from the thickness of the expanding back faces rather than from the correctly oriented front faces. If we didn't use back faces, we just get a simple filled color that grows and shrinks, which wouldn't look right. It's not the perfect method, but it does the trick effectively. This is our core concept, and it's really that simple. Now let's refine it further for more control. One improvement I like to add is a Fresnel node, with parameter based on our first two existing inputs to better control the distribution of the outline. This helps reduce overly aggressive outlines, particularly in areas like the face. Since we're working with back faces, inverting the Fresnel logic can give us better results while staying consistent with our initial setup. Another useful enhancement is adding a stroke effect to the outline. We can achieve this by using a texture mask, like one from an older Free for the Month pack for example, and you could work with any regular mask you got. The logic is simple. First, adjust the orientation and coordinates of the texture. You can use the texture coordinate node along with the custom rotator material function already available in Unreal Engine. With the multiply and an append node, you can scale U and V separately, allowing precise, non-uniform control over the stroke effect. And to refine this further, you can add a scalar parameter with the multiply to control the overall intensity of the effect. Don't forget to invert it, otherwise the effect will cover the entire mesh instead of just the outline. Finally, combine the original opacity setup with the new stroke effect using a divide node. Now that everything is connected, we have a lot more control to fine-tune the effect. And that's awesome, right? One last trick I want to show you is a cool adjustment that can also be used to create animated effects. Let's dive into that next. Based on the bounding box based material function node, we can create a gradient effect or control the outline based on the z-axis. These allow us to adjust the outline's placement, so for example, you don't want too much of the outline on the character's face, or you might want to create a spawn gradient effect. This node works by referencing the object bound and the warp position offset, making it an excellent tool for this purpose. Using the B output for the z-axis, which works like regular world position logic, I'm going to invert it first, just like we did with the other logic. Then I multiply it by a scalar parameter to control the gradient's behavior. Additionally, I add a cheap contrast node with another scalar parameter to adjust the intensity of the gradients. This lets us control the outline effect, such as lowering it on the face of the character or emphasizing the bottom of the mesh. It also allows to invert the effect, making the gradient start from the bottom or top as needed. To integrate this into our existing logic, we can simply use another multiply node and connect it all together. Now you can play around and create a variety of effects for your outline, from controlling the color to adjusting the gradients and outline width, all managed by a simple material. Here's the final version of the material again, so you can double check and ensure your setup is exactly the same. Now you know how I create these outline effects on my character. Hope you find it useful, guys, and as you can see, no need to overcomplicate things. Sometimes you just need to play a few tricks, and after all, this is kind of our job as a 3D artist, right? Thanks for watching and see you next week for a new video. Ciao!